This is Alan Ruberg, the Chief Technologist for the WISA organization again, and I'd like to talk about the frequency spectrum that the WISA technology uses to communicate. It's in a unique area in the 5 gigahertz range that avoids most Wi-Fi traffic. So if I were to observe instead the 2 gigahertz space, this is what is happening right now in the Venetian, and you can see each one of these boxes represents one 2.4 gigahertz Wi-Fi network. So in wireless N, there are only 3 channels available, and you'll see that we have quite a few networks, and then there's a whole lot of traffic here in the middle. So this is not practical for most audio applications. Now if we go to the 5 gigahertz space, where there are many fewer users to begin with, they are clustered at 5.2 gigahertz, which is this area here, and then 5.8 gigahertz, which is up here. So the part in the middle between these two is used very rarely because it has to avoid conflicts between weather and military radar. So the network has to constantly monitor these frequencies to observe conflicts. And what the technology is doing is it's looking for the radar signatures, and it will change instantly to those. So we have 3 systems running in our suite, and you can see these from these peaks. They will avoid each other, they will avoid other traffic, and of course they will avoid radar. Audio is purpose-made for this band because with a computer network you have to stop transmission in order to monitor the radar. So that causes bandwidth problems and network interruptions. For audio, there are always gaps. You know, a few samples come out and then there's a gap, and you can use that gap to monitor the radar. The system actually has 2 antennas, one for monitoring the next channel that's to be used, and then one for both transmission of the audio signal and also monitoring the current channel. If there are any conflicts, no matter which kind of network, then the next channel in this range has to be monitored for 1 minute before it is used, and it can't be used again for 30 minutes. So it's important to stay in this band, and having the extra radar detector helps the system to be able to continue to stay in this special area. And that is how this system achieves up to 96 kilohertz of 24-bit high-end audio. Thank you.